Okay guys, now what I want to introduce to you guys is I want to introduce IV calculations. There's a number of different things we can do with IV dosages. A lot of different places you're going to see those show up, especially as you guys get deeper into your nursing classes. They're going to start showing up on your ATI proctored exams, and you'll see this a lot, along with the dosage calculations from last week. But I want to start off with kind of the basics, that what we can do to understand IVs. There's a couple different things we'll be able to do. IVs, you can calculate, given information, you can calculate exactly how many milliliters per hour a patient is going to receive an IV, at a certain, at that flow. So that's called the flow rate. You can even calculate it to an extreme of just figuring out exactly how many drops per minute a patient needs to receive based on information that has been prescribed. So what we're going to see here, I'm going to start with actually drops per minute, as drops per minute is kind of our unique formula in this chapter. So you're actually going to see this sometimes as GTTS/minute drop. That's the abbreviation for drops. So it may be written out as actually the word drops, or you'll see the abbreviation GTTS. But that stands for drops per minute. And here's what's going to happen in these types of questions. You'll be given three things. One, you'll be given a volume. So I'm going to write V for volume. In the drops per minute formula, you're trying to calculate, again, exactly how many drops they need each individual minute. Our volume has to be in a particular unit. We need to make sure it's in milliliters, which is standard. A lot of times when an IV is being ordered, it's ordered as 1,000 milliliters, 1,500 milliliters, 500 milliliters. That's very common. Every once in a while, you might get a physician that says, give that patient 2 liters of blah, blah, blah. And then it's ordered in liters instead of milliliters. Very, very similar to what we did last week. A quick way that you can convert liters to milliliters if absolutely necessary. Keep in mind our metric chart. So our kilo, hecto, deca, base, deci, centi, milli, XX, and micro. Remember, liters is one of your bases, so that's here in the middle, whereas milliliters is milli. So it's the exact same conversion as grams to milligrams. This is liters to milliliters. It's just a different base. It's dealing with a volume instead of a weight. So it's the exact same movement. You just take it and move that decimal 3 places to the right, or again, it's only down 1 step on the stair-step method. So liters to milliliters would be times 1,000. So if for any reason you get a physician that orders liters, make sure we get it in milliliters. So that's what I'm going to write down in red as I go through this video here. That's kind of my way of saying, don't forget we need it to be in that unit. That also goes along with the time. What we're going to do is we're going to take that volume that's given to us, and we're going to divide it by the time that's given to us. Since we're trying to calculate drops per minute again, so just reminding you that we're calculating drops per minute, that's kind of a clear indication that we want to make sure our time is in minutes, which is actually rare. Most of the time, IVs are given over a long period of time, so 1,000 milliliters to be given over 8 hours, to be given over 16 hours, to be given over 12 hours, sometimes a full day, so over 24 hours. So we're going to have to do here is we are going to have to convert from hours to minutes to make sure that they are in minutes in this case. And we know there are 60 minutes in an hour. So if, say, doctor orders over 1 hour, we know that we would use 60 because that would be 60 minutes. If a doctor orders over 2 hours, we know that would be double 60 minutes, so that would be 120. 3 hours would be triples, would be 180, and so on and so forth. So anytime you get hours and you need to convert that to minutes, we are simply going to multiply that by 60. So keep that in mind as we're doing these conversions. The last step in calculating drops per minute is we are going to then multiply by what's called a drop factor. That's something you're also going to just be given in these questions. So I'm going to write it out as drop factor. But the units for our drop factor, these will be given. So this will never have to be something you'll have to convert. But a drop factor is what's called a drops per milliliter infusion rate. So it's just standard based on the size of the IV tubing that's being used. So whatever you're given to use, that particular IV has a particular drops per milliliter infusion rate. So how many drops are given with each particular milliliter? It'd be different if there was a, if it's a thick tube versus a thin tube, a very small tube would administer, smaller drops. So we would have to give more drops to administer a full milliliter, whereas a thicker tube, the drops are going to be bigger, so we would need fewer drops to administer a milliliter. So that's what I mean by that drops per milliliter infusion rate. So what's happening here? If you guys recall from last week with our our dosage calculations, remember when D and H were the same unit, so that was something that was also discussed on our review video today. D and H are the same unit, and when they're opposite numerator denominator, they cancel each other out. And the same thing is actually going to happen here. It's what happens if we look at just the units in this particular calculation, and we'll see a couple examples with this. But what you're looking at with just our units, if I write that out in green down here, we can see milliliters over minutes that are going to be multiplied by drops over milliliters. So we see a similarity here. Opposite numerator denominator across from one another, we see the exact same unit of milliliters. Therefore, they too, just like when we did this with our dosage calculations, they too will also cancel out. Meaning at the end of this problem, the only two units I'm left with are drops and minutes, which is exactly what we're trying to convert here, is drops per minute. So that's why our time needs to be in minutes in this formula. That's why our volume needs to be in milliliters, because I need this to happen. I need that cancellation to happen so that I'm left with exactly what I want, my drops per minute. So I want to give you guys an example problem here. So let me get all this craziness out of the way here. Okay, there it goes. Okay, so I'm just kind of standard here, just kind of basic. If I gave you a word problem that had some information in it, but it said that I want to calculate drops per minute. Remember, I'm looking for three things: a volume, a time, and a drop factor. If I'm asked to calculate this, again, if it tells me you need to find drops per minute, those are the three things I need. So if, let's say, a physician orders 1,500 milliliters over the course of, let's say, 12 hours, using a drop factor of, let's just say 20. So a 20 drops per milliliter infusion rate. So again, sometimes you got to look out for more information. Sometimes there would be more information in the problem, and that's just irrelevant information that you just have to ignore. That happens sometimes. But I'm going to start off pretty straightforward. The ones you might see from me are just going to be pretty straightforward like this. We'll get into some different ones here in just a little bit. But when I'm calculating drops per minute, what I want to do is I want these three things, and I want to put them in the formula just as I was asked earlier. I need to make sure that my volume is in milliliters. So I'm going to write the whole problem out here using the formula, plugging that in down here in blue. 1,500 milliliters over the course of 12 hours. Now keep in mind, remember our volume over time in our drops per minute formula, time has to be in minutes. So a little refresher up here as what our formula should look like. So I'm going to convert these hours into minutes. So I'm going to simply, just as I mentioned earlier, I'm simply going to take 12 and multiply that by 60, and that's going to give me 720. So I'm going to use 720 minutes down here, and then we'll just multiply by our drop factor of 20. So what happens is we just take 1,500, divide by 720, take that answer and multiply by, let's see, oops. I'm sorry, I'm messing up on my calculator here. 1,500 divided by 720, take that answer and then multiply by 20, and that's going to give you a decimal of 41.666666, repeating. So we're just going to round that off to 42. And the reason why we do round that off to the nearest whole number, drops cannot be regulated as far as the size. You can't give half a drop, or you can't give a quarter of a drop, or in this case 0.6 of a drop. So instead, drops are always going to be rounded to the nearest whole number, and that will be the same thing on your ATIs as well. When you get to that point where you're having to do dosage calculations, IVs, when you're calculating those. Now, if the answer is in milliliters, that's different because you can give, 0.7, 0.8. You can give a decimal in milliliters, but drops you can't. Drops are really small. I mean, think about if you've ever administered drops out of a dropper. It's hard to say, okay, well, instead, now I'm going to give you just 0.25 drops. That's a quarter of a drop. You can't do that. So drops are always rounded to the nearest whole number. So looking at another example, calculating drops per minute still. Let's say a doctor has ordered to give, let's say they want to give 2 liters of some solution over the course of, let's say, 16 hours using a, let's say 60 drops per milliliter infusion rate. So 60 drops per milliliter infusion rate. And I'll tell you guys too, sometimes if you ever see micro drip tubing, micro drip, if you ever see that, that is a term given to this particular drop factor. Micro drip is always standard at 60. So if you ever see micro drip, that just means that your drop factor is 60 drops per milliliter. So maybe you're asked to calculate drops per minute, but you're not seeing a drop factor in there. If you do see the word micro drip, that's what that means, is that it's telling you to use the drop factor of 60. So just kind of a heads up for future reference. So in looking at this particular problem, remember our formula is volume, but the volume needs to be in milliliters, our time needs to be in minutes, and our drop factor will be given. So in this problem, our volume is given in liters instead, so we're going to have to convert that. So remember, using our metric chart or using our stair-step method, that's either 3 places to the right or times 1,000 because we're going down a step. And that would take that 2 liters and that would convert to 2,000 in terms of milliliters. So I'm going to use 2,000 in my problem here. So that's what we have in milliliters. Again, 2 liters and 2,000 milliliters are the exact same thing, so I'm not changing anything, just looking at that in terms of milliliters instead. And then I'm going to divide that by our time in our time in minutes, since our time is given in hours, just like we did on the last problem. I'm going to take that time in hours and multiply it by 60, and that's going to give me 960 minutes. And then I'm going to take that and multiply by my drop factor. So now I've got everything plugged into our formula. So I'm going to go ahead and to finish this, I'm going to take 2,000 divided by 960. I'm going to take that and then multiply by 60, and that gives me a drop rate of 125 drops per minute. So that's how we calculate the drops per minute. So just keep that in mind. Is anytime you're looking for or you're being asked for drops per minute, then we need to look for those 3 things. So that's our formula for that. And I'll give you guys this formula next week just because we're taking a look at this, for the first time here. I'll give you guys these basic formulas here. So in looking for this, I'll even remind you that this is our drops per minute formula. So we just need to plug those values in. So we look in the problem for those 3 values. The next couple formulas we're gonna look at now all kind of relate to one another, meaning that the formula can be rearranged. So let me show you what I'm going to look at now, and I'll explain what I mean by that. We're going to look at what's called flow rate now. So I'm going to write F for flow rate, and I'll even put down here that stands for flow rate. But what flow rate is, a little bit different than drops per minute as we just looked at. But a flow rate is a milliliter per hour rate. So meaning how many milliliters of liquid a patient is getting of this IV each individual hour. And starting just with a real kind of short and sweet example, let's say if I told, a nurse that they need to make sure that the patient is getting 200 milliliters over the course of a total of 2 hours. So a short IV, but they're getting 200 milliliters over 2 hours. In thinking about this, just trying to think about this a little bit logically, then based on just this information here, 200 milliliters over a total course of 2 hours, how many milliliters would they be getting then in just an individual hour, in just 1 hour? Well, based on this, you might be looking at this and thinking, well, that means they're going to get 100 milliliters per hour. They're going to get 100 milliliters the first hour, 100 milliliters the second hour, and then they're done with their IV. Over 2 hours, we've administered the full 200 milliliters. And what we did, and that's correct, because what you guys did is you all took that total volume in milliliters, and you divided it by the total amount of time that they're supposed to receive that IV. And you'll notice in this question, there are no numerator denominator that are the same, numerator and denominators that are the same, so nothing cancels out. We are taking the total amount of milliliters, dividing it by the total amount of hours. So since nothing cancels out, I'm left with milliliters per hour, which is exactly what I'm trying to solve here. So when you're asked to find milliliters per hour, all you're going to be given is is a volume to be given over a certain amount of time. And all we need to do is divide those two numbers, and making sure that your time is in hours in this case. A little bit different than the last formula when we were calculating drops per minute. They obviously needed to be in minutes. So what we may see a little bit further here, if I said that a patient needs to receive, let's just say 2,000 milliliters over 16 hours. So kind of similar to our last problem, except in our last problem, we had to convert the hours into minutes, and then we needed a drop factor. And that was for when we were calculating drops per minute. But here, if I said, okay, well, what is their flow rate in milliliters per hour? Well, I'm going to have to do then is just take that 2,000 milliliters and divide that by 16 hours. So, again, we have them both in the correct units that I need them to be in there. I don't have to convert anything. I'm just going to take 2,000 divided by 16, and that's going to give me a flow rate of about 125 milliliters per hour. 125 milliliters per hour, and that's our answer. That tells us exactly what they're going to get each hour. That's their flow rate. That's the rate that they are receiving this IV. Be on the lookout too for liters. If I have a doctor who says that a patient needs to receive 3 liters over a day, let's say over 24 hours, then again, remember our flow, we're trying to calculate milliliters per hour, not liters per hour. If I were to take 3 divided by 24 right now, that would tell me how many liters they're going to get each hour. But I want to know what that is in milliliters per hour. So just like we did in a previous problem where we had to convert the liters to milliliters, we want to make sure of that's the correct unit that we're using. We had to use our metric chart. So remember, base to milli is 3 places to the right or down 1 step. So I'm going to multiply by 1,000 for those of us using that one. So I'm going to take 3 times 1,000, or the decimal behind the 3, and move it 3 places to the right, and I'm going to get 3,000. 3,000 milliliters. So again, we're not changing this at all. We're just we're just saying that, hey, 3,000 is equivalent, 3,000 milliliters, I should say, is equivalent to 3 liters. So that's what I'm going to use in this case. Take that and divide by 24 hours. And again, that's going to give me milliliters per hour when I divide these two. So let's do that. 3,000 divided by 24. Well, coincidentally, that just happens to be 125 milliliters per hour. Sorry about my sloppy handwriting over here. But that would be their flow rate in milliliters per hour. One other thing to be on the lookout, this is a rare occurrence, a very rare occurrence, but I know it's come up on ATI questions before. Let's say that a patient was told they need a smaller IV, a short IV, I should say. They are told that they need to take be given 150 milliliters over 30 minutes. A little bit different here with those minutes. Because remember, our flow rate formula says that we need a volume in milliliters, and we need to divide by our time in hours in order to get that milliliters per hour that I'm looking for. By dividing milliliters in hours, it'll give me milliliters per hour. If I were to take these two right now and plug that into the formula, 150 milliliters divided by 30 minutes, if I divided these two just now, that would tell me how many milliliters they're getting per minute. I don't want to know milliliters per minute. I want to know milliliters per hour. So what I'm going to have to do is I'm going to have to convert the 30 minutes here into hours. So off the top of our head, you guys might be thinking, well, 30 minutes is half an hour. That's correct. 30 minutes would be 0.5 hours. But if it's not as easy as something like that to do in our head, remember, opposite of what we did on our drops per minute formula. In that particular formula, we needed our time to be in minutes. So in all of those questions, we were converting our hours to minutes by multiplying by 60. So like when we were given 12 hours, we took 12 times 60 to get 720 minutes. When I had, if I had, I think 16 was one example. If I had 16 hours, I had to take 16 times 60, and that gave me 960 minutes. Here, it's the opposite. My time is given to me here in minutes, but I need it to be in hours. So the opposite conversion would be division. Instead of multiplying by 60, but like we did on the previous section, I'm going to divide by 60 here. To convert my minutes to hours, when I want to do that, I'm going to just divide by 60. So you might want to add that to your notes there. So what we did is we took 30 divided by 60, and 30 divided by 60 is half, or 0.5. So that's why we're using this in this problem. Because again, and the reason why we're doing that is because we're trying to calculate milliliters per hour, so it needs to be in hours. So now when we get it into the right unit, that's what we're going to get at the end of this problem. So I'm going to take 150, divide that by 0.5, that's going to give me 300 milliliters per hour, which makes sense. If they're getting 150 milliliters in a half an hour, then if given 150 milliliters the second half, that would give them a total of 300 in a full hour. But that's what flow rate means, is I need to know what that rate would be in a full hour. Even if they're not going to get that full amount, that's still considered what the flow rate is what it would be in a full hour. So be on the lookout for this. I had a student come up to me the other day asking me for help on a worksheet she was looking at, and it had something very similar on there. In fact, it had something like a patient was told that they needed to take 500 milliliters over 90 minutes. So very, very similar case here, that it was given in minutes, and the question was asking her milliliters per hour. So she wasn't sure what to do on that, and I told her, just convert your minutes into hours then. And so when you do that, 90 minutes is an hour and a half, but you can quickly see that if you took 90 divided by 60, calculator's going to give you 1.5. So for this problem, to calculate the flow rate, all I have to do is use my volume and divide by 1.5 hours, because that's what 90 minutes represents. So 500 divided by 1.5 is a flow rate of about 333.3 milliliters per hour. And and I don't know what I'm writing right there. On an ATI exam, when you get an answer like this, you guys are probably looking in your calculators right now, and it says 333.3333333 repeating. An ATI exam would tell you to round it to the nearest tenth, typically. It'll be very specific on how you want to round that. So that's why that would be 333.3. We would just stop at the first place after the decimal. The tenths place is just the first place after the decimal point. So keep that in mind too. So that's our flow rate. Now, those are the two most common things that you guys will see in terms of IV dosage calculations, where you'll be asked to calculate drops per minute. And again, of all the information in the problem, keep an eye out. We're looking for drops per minute. I need a volume, a time, and a drop factor. Keep in mind that your time has to be in minutes. For flow rate, we just talked about how in order to calculate milliliters per hour, your flow rate, you need a volume and a time. But since I'm calculating milliliters per hour, make sure your volume's in milliliters and your time is in hours. Every once in a while, in this problem, that's what we were given, is we were given volume, we were given time, so that's how we could calculate flow rate. Every once in a while, you may be given the flow rate and the volume, and if you're given those two things, from there you should be able to figure out how long an IV takes. what I can do is I can rearrange this formula then to figure that out. And you guys are familiar with algebra and being able to rearrange this formula, but I'm actually going to go ahead and do that for you. How we would do that is we would simply just, if given the volume and the flow rate, to figure out how long that would take, your time, what we're going to do is we're going to take that total volume and I'm going to divide it by the flow rate. Let me tell you guys, again, how we talk about canceling out. You guys see, looking at this formula, if I took the volume divided by the flow rate, what's going to happen here is opposite numerator denominator. We see some similar units. Those milliliters will cancel out and leave me at the end of this problem with the amount of time in hours, how long an IV will take. So starting with something kind of simple, if I said, okay, well, a patient needs to be given 500 milliliters at a flow rate of 100 milliliters per hour. So let's think about that logically for a second. They're getting 100 milliliters each individual hour until they reach a total of 500. So they're going to get 100 milliliters in 1 hour, 100 milliliters in hour 2 to give them a total of 200. Hour 3, they'd get another 100 milliliters. We're now at a total of 300. In hour 4, they're getting another 100. You guys see where I'm going with this? We know that that's going to end up taking 5 hours. And so that's what we've done, is we simply can just divide those two numbers. Total volume divided by the flow rate will give me the amount of time it should take to receive that IV. So no matter what you're given, even if it's something we can't easily do in our head, again, to calculate time, you just take your total volume, that's the total volume, divided by the flow rate. And the flow rate will be given as milliliters per hour. So if, let's say, I said that a patient needs to receive 2,000 milliliters, let's say 2,000 milliliters at a rate of, let's say, 150 milliliters per hour, at a rate of 150 milliliters per hour. Let's see how long this IV should take. So we're going to take that total volume, divide it by that flow rate. If you guys have done that, what that's going to do is it's going to come out to be 13.3. Now, so that's going to take about 13.3 hours. Now, in terms of time, you guys might be looking at that and say, what is 13.3? Time is measured in hours and minutes, not decimals. Typically, you guys are going to get answers, at least from me, and most of the time on your ATI assignments too, your time will come out to be an even amount of hours. But every once in a while, that might not be the case. You might get this decimal. I'll tell you guys, for me, if you get a decimal on your answer for on the final exam, leave it as a decimal. Just leave it as 13.3. But I'll tell you guys, just for curiosity's sake, if you get something like this, what does that mean in terms of actual hours and minutes? Well, remember, time is based on 60 minutes. You know that there are 60 minutes in an hour. So the same reason why we just looked at a second ago, we said that the decimal 0.5, if you guys remember, we saw this in one of our previous examples. That's the exact same thing as 30 minutes when we're dealing with hours and minutes. That the decimal 0.5 meant 30. So there's not a big similarity between what the decimal looks like and what that equates to in minutes. So a real quick, real easy way to figure out what that would be in terms of hours and minutes. This is definitely our answer that we've received here, 13.3. This is definitely 13 full hours. But the 0.3 is going to be what it is in minutes. Real quickly, to convert that to minutes, all you need to do is take that decimal of 0.3 and multiply that by 60. When you do that, it'll tell you what that would be in minutes. And if you take 0.3 times 60, you get 18. 0.3 would be 18 minutes. Again, 0.5 is half an hour, so we're not quite to half an hour yet in that point when we have 0.3. 0.25, if you guys think of a clock, just to kind of relate this a little bit to something that might make a little bit of sense. Well, I don't know what I just drew right there. I was trying to draw a circle. That was not a circle. In a clock, if you guys think about how time goes by, again, a full circle on a clock would be 60 minutes. So why, when you go around in a full circle, but half would be 30 minutes, right? But if we don't quite make it to half, but we make it, to a quarter of the way down the clock, that's actually going to be 15 minutes because it's halfway between 0 and 30 minutes. And then 3/4 of the way through this clock, that's 45 minutes. And then we make it all the way around, that's 60 minutes. So a quarter in terms of decimals would be 0.25. So if you think about the relationship there, 0.25 would be the same thing as 15 minutes. 0.5 is the same thing as 30 minutes. 0.75 is the same thing as 45. Well, 0.75 is the same thing because that's 3/4 is the same thing as 45 minutes. And then 60 minutes is a full hour. So just to kind of get a better understanding of why those decimals translate to this in terms of minutes. So again, a quick way to just get that to hours and minutes would be to take that decimal and multiply it by 60. Let me give you guys another example, and then I'll do another one that ends up with as a decimal so that we can convert that to minutes. So let's say we have a patient who is told that they need to take, and this one, let's do this one because this one will make a little bit of sense. Let's say, well, hold on, let me think. Let's say a patient needs to take 1,500 milliliters at a flow rate of 200 milliliters per hour. 200 milliliters per hour. So again, how we're going to calculate this is we're going to take that total volume of 1,500 milliliters, and it is in milliliters, so I don't need to convert it to anything. I'm going to divide it by my flow rate of 200. So I'm going to take 1,500 divided by the flow rate of 200. That gives me 7.5 hours. And again, 0.5 we're pretty familiar with. 0.5 means half an hour, so we know that is 30 minutes. But if you want to double check that, 0.5 multiplying that by 60 does give us 30. So that means 7 hours and 30 minutes is how long this IV would take. Like I said, guys, on the final exam next week, if you give me 7.5, I'm going to mark that right. Do not think that you need to put this in the hours and minutes and go to that extra step. But I just want to show you that because I know I have a lot of students that, for curiosity's sake, they go, wait a minute, time is not measured in decimals, so what does that even mean? So that's how that would translate. So that's how you calculate the total time. Be on the lookout too, is you may go into a little bit more detail with that time. Let's say, same exact thing. Let's say that, if I asked you something like this, it would be if there was an even, it wouldn't be if there was a decimal, it'd be a whole number. So let's take another example, and I'm going to show you guys. Let's say a patient was told that they need to take 2,000 milliliters at a rate of 200 milliliters per hour. So they're getting 200 milliliters each hour until they receive that total volume of 2,000. So when I divide these two, I know that that's going to end up taking 10 hours. So what I was getting ready to say is be on the lookout for a little bit more to the question. Let's say with part of this question, I said that a patient started an IV at 8 a.m. Let's say they started this IV at 8 a.m. In this IV, they are receiving 2,000 milliliters at a rate of 200 milliliters per hour. What if instead of just saying how long is this IV going to take, what if instead I said, what time should this IV be finished? So just take a look at that. Remember that, yes, I'm going to need to do this to see first, for my sake, how long that's going to take. But then you're going to have to add that to the time. So if it started at 8 a.m., then we know 12 hours from then would be 8 p.m. So, but since this was only going to take 10 hours, 2 hours right before that, this should finish at 6 p.m. So I'm looking for this answer instead of this one. So I'm looking for what time that would be finished. So sometimes with those, you might be able to take that a step further and be very specific about the time that it would be finished. So look out for those too. The other formula that you may see, again, I showed you guys with that flow rate formula. Our flow rate formula was volume over time. But we just took a look at what happened if I was given the volume and the flow rate. I was able to then calculate the last part, the time. But what if I'm given instead, what if now I'm given the flow rate and if I'm given the flow rate and the time? From that, I should be able to then calculate the volume. And that's what we're going to see here in this last formula. So just to give you again one to just think about before we even look at the formula for that, let's say I am given a situation where a patient has been told that they need a particular IV. I know that they need it at a rate of 100 milliliters per hour, and they need it for a total of 5 hours. For a total of 5 hours. And then my question is, well, how much total volume will they receive at the end of this IV? Well, let's think about this one for a second. This is relating to the first example I gave you guys in the last section, that if they're receiving 100 milliliters per hour, that means they're going to get 100 milliliters in an hour. In the next hour, they're going to get another 100 milliliters, giving them 200. In the third hour, they would then end up with 300. After the fourth hour, they would end up with 400. And you guys see where I'm going with this? They're going to receive a total at the end of this IV, a total of 500 total milliliters. So what you can see we've done here is now we've just multiplied by these two numbers. When you're given the flow rate and the time to calculate volume, we just need to multiply those two. So volume, this formula will also be provided to you guys as well as the other three, so don't worry about that. But to calculate the total volume, we're simply going to take that flow rate of, again, milliliters per hour, and I'm going to multiply it by my time in hours. And what's going to happen here, if we were to just look at only the units in this problem, you're going to see exactly where I'm going with this because we've seen this many times. We're taking this and we're multiplying by this. So hours by itself, that's the same thing as hours over 1, so not that that's completely necessary. But you're going to see that what's going to happen is the unit hours is canceling out, leaving me with just milliliters, which is just the total amount of fluid that they're going to receive in this IV. So all we're doing here is multiplying. So if, say, I was given a situation where a patient was told to take, let's say, or not take, but they're told that they need to receive an IV at a flow rate of 150 milliliters per hour, and they need this for 12 hours. From this, I should be able to figure out the total volume that they're going to receive by taking 150 times 12. All I'm doing is multiplying these two numbers, and they're going to receive a total volume of 1,800 milliliters. So all we're doing there is just multiplying those two numbers to calculate the total volume. So if you're asked for total volume, multiply. A little bit different than our other formulas there. If a patient needs an IV at 125 milliliters per hour, that's a 5. Sorry about that little swirl there at the end. That's a 5. 125 milliliters per hour over 24 hours. So over the course of the day, I'm going to take 125, multiply it by 24. At the end of the day, they're going to have received 3,000 milliliters of fluid. All right, guys, so I hope that helps with your basic formulas. I actually have one other thing that I want to show you all with these IVs, that not just utilizing those basic formulas, but now I'm trying to kind of put it together. And I show this because I know this is definitely going to come up on your ATIs as well. But what if we are told, and this is actually going to relate to what we did last week too. Some ATI questions will do something like this. If I say that, let's say a patient has been ordered to take, let's say, 50 milligrams of drug per hour, and the IV, I need to know what they're going to take in milliliters per hour. Now, I know that they're getting this amount of drug in an hour, this 50 milligrams. That's how much total drug they're receiving. So I know that that's good. I'm good as far as how long they're receiving that. It's already converted to hours for me. But how do I get from milligrams to milliliters? This is going to relate to what we did last week. that in order to convert something from milligrams, from a solid substance, into a liquid substance of milliliters, that must mean that the medication is diluted and comes that way. So what's also going to be given to us in these particular questions is a supply dosage, meaning that it's going to tell us that, okay, well, how this medication comes is it actually comes as 25 milligrams per milliliter of liquid. So it tells us, just like we did in dosage calculations, that if this is the dosage that we have on hand, then we're going to take that 50 milligrams of the ordered dose, divide by how it comes of 25 milligrams per a quantity of 1 milliliter. We need a supply. We need some type of a supply for how this medicine comes in order to get it from milligrams into milliliters. So if you ever have a question like this where I need to do so, there's going to be some information like this in the problem. And that's what happened here. We can take that and we can take 50 divided by 25 times 1. That means that they are going to receive a total of 2 milliliters per hour. And I say it's per hour because it was already ordered as per hour. And so since we're looking for hours, we didn't have to convert that to anything. That's the unit I wanted it to be in. But be on the lookout for any type of conversion where if, let's say in same case, if let's say that was instead of 50 milligrams per hour, let's say a doctor orders 50 milligrams per minute. Patient needs to receive 50 milligrams per minute. So what's going to have to happen here is two things need to be done now. If it's asking me for milliliters per hour, I'm going to need to do two conversions. One, I need a supply dosage. I need to figure out, like we saw in the last one, in order for me to get it from milligrams to milliliters, I need to know that it comes in so many milligrams per milliliter or whatnot. That's the solution. Again, if it comes in grams or micrograms per milliliter, we might have to do some converting, but I need a supply dosage. I need to see how it's been diluted. And then to get from minutes to hours, well, we have to do our conversion using 60 minutes. If we think about this in a little bit more detail, if a patient is receiving a drug of 50 milligrams per minute, that means they're going to receive this amount, this 50 milligrams, they're receiving that 60 times because they're receiving that over the course of 1 minute. So in 2 minutes, that's going to double. In 3 minutes, that's going to triple. In 4 minutes, that's going to quadruple. You see where I'm going with this? That in 60 minutes, they're going to receive quite a bit of medication. So if you want to see what that is per hour, we simply just take that 50 milligrams and multiply it by 60. That means this person is receiving 3,000 milligrams in a full hour. So you can always do that first. Convert it to your hours first by multiplying by 60. Now we've already got it in hours, so we're good with that part of what we're looking for. Now I just need to see how it comes and how it's diluted, and let's say it's the same medication that was 25 milligrams per milliliter. So that tells us that based on how this is diluted, in order for us to get it to milliliters, I'm going to have to put it into a dosage formula. So 3,000 milligrams is what's been ordered per hour, and we're going to take that divided by the supply that it comes in, 25 milligrams per milliliter. So 3,000 divided by 25 is 120 times 1 is still 120, so that means this person is getting 120 milliliters each hour. So that's what we're doing here, is we just need to, we may have to do two parts to get it, from what's been ordered to what we, need to get to. So I always tell people, pay attention to what's being asked. What is the question asking us? And in these questions, if the question is asking for milliliters per hour, great. I need a volume and I need a time. Sometimes that might not be given to us. It may be given to us as a dosage. And if that's the case, if it's a dosage of a particular strength of medicine, then I need to know how it comes, according to the label to see how it's diluted. If it doesn't come in hours, we need to get it into hours. So let's take a look at another example. Let's say that a patient has been ordered that they need to receive 5 milligrams per minute. And that medication that they're taking is in liquid form, It is an IV. It is diluted as, it is 25 milligrams per 2 milliliters. And I want to know what they're going to receive in terms of milliliters per hour. What's their flow rate going to be? So again, what's happening here is based on the fact that I was given this and I'm trying to get here. Two things need to be done. I need to convert my milligrams to milliliters, and that's going to be from this information right here. In order to get from a solid to a liquid, I have to see how that solid has been diluted. So based on that supply dosage. I then also need to get from here to here, my minutes to hours. And again, in order to do that, I'm going to multiply by 60. Honestly, guys, it doesn't matter which one you do first, because as long as you do both of them, you're going to get the right answer. If you go ahead and put that into a dosage formula as 5 divided by 25 times 2, that's fine. Then just take that answer and multiply by 60, and you'll get your answer to get it in hours. But just one step at a time. Last question, we took that and we multiplied it by 60 to see what they're getting in terms of a dosage per hour. If they're getting 5 milligrams per minute, that means they're getting 5 times 60, they're getting 300 milligrams in an hour. So you may look at that as the ordered dose. They're getting 300 milligrams, and now it's already per hour, so we don't have to really think about that part anymore. We're done with the minutes to hours. We just know that that's our ordered dose. It comes as 25 milligrams per 2 milliliters. That's a 2, not a 3, 2 milliliters. So I take 300 divided by 25, taking that, multiplying by 2, they're going to get a flow rate of 24 milliliters per hour. I told you guys too, you could have done the other one first. Let's say we converted our milligrams to milliliters first and we did the hours part second. So let me erase that and let me get all this out of the way to show you why that still would have worked. I was ordered to take 5 milligrams per minute based on a medication that comes 25 milligrams per 2 milliliters, and I want to know what it is in milliliters per hour. Like I said, two parts are needing to be done. I need to convert my milligrams to milliliters and my minutes to hours. Let's say you did the first one first. Based on that supply, you went ahead and put that into a dosage formula. If you did, you would have ended up with 5 milligrams divided by 25 milligrams times 2 milliliters. That's totally fine, because what we're calculating here by taking 5 divided by 25, taking that, multiplying by 2, gives us 0.4. 0.4 milliliters. We have converted our milligrams to milliliters. We did step 1. But this is milliliters per minute. Since I haven't multiplied anything by 60 yet, this is still how many milliliters they're getting in a minute. I knew originally what it was in milligrams, but by incorporating this, I know what it is now in liquid form. But now I need to figure out what it would be in a full hour. So I simply just take 0.4, take that and multiply it by 60, and how many milliliters would they be taking in an hour? Same answer we got in the last one, 24. So they're still getting 24 milliliters per hour. Does not matter which one you do first, just as long as you make sure you're doing both of those to get to this point, what we're being asked. I need it to be in milliliters per hour, not milligrams per minute. So that's what we have to incorporate here. So no matter how it's given to us, in some of the videos that I sent to you guys, some of those go a little bit deeper into, what if I was told that a patient needs to take, going even further, let's say 4 micrograms per minute. Oh, now we're getting even crazier, but that's okay, because we know how to work with metrics. Same exact scenario. Let's say a patient needs to take 4 micrograms of this liquid per minute. This medicine is still diluted as this one is diluted as, let's say, how about 0.5 milligrams per 5 milliliters. And I want to know what they need in milliliters per hour. So once again, 2 steps have to be done. I need to get from here to here. I need to get from a dosage to a liquid. So from micrograms to milliliters, and I need to get from minutes to hours. The minutes to hours conversion is still going to be the same, times 60. The dosage to liquid is also still going to be the same. We have to incorporate this supply up here, and that's okay. Even though I know you guys are seeing that as micrograms, that's different. Think about what we did last week. When we have 4 micrograms, and I wanted to put that into a dosage calculation as milligrams per milliliter, or this one, I'm sorry, 5 milliliters, what did we do? When our units were not the same, we just simply had to make one match the other. And we can do that. We can either take that micrograms and convert it into milligrams, or convert those milligrams into micrograms so that they both match. I'm in the habit of getting everything into milligrams, so I'm going to convert that 4 micrograms into milligrams. So that would be 3 places to the left, or dividing by 1,000. And so that would give me 0.004. That's what it is in milligrams. Confusing looking because of all the decimals, I know, but let's go ahead and divide that out. 0.004 divided by 0.5, multiplying that by 5. That means that this person needs 0.4 milliliters per minute. Again, I haven't done anything with that by multiplying by 60 yet, so since this is what they're taking per minute, I take that and multiply by 60 to see that they need 2.4 milliliters per hour. And again, you could have done it the reverse. You could have said, I'm just doing the same question, guys. I'm just erasing this to get all that confusion out of the way. If the order dose was 4 micrograms per minute, and you needed it to be in milliliters per hour, just a second ago, we did this one first. We did the micrograms to milliliters first, and then multiplied it by 60. You could take that and multiply by 60 first. Shoot, and I already forgot. What was the dosage on that? Oh, I think it was 5. Oh, no, I'm sorry. It was 0.5. Sorry, I had a brain fart for a second. It was 0.5 milligrams per 5 milliliters was our supply dose on that one. But again, you can take this and multiply by 60 first. If you took 4 times 60, and remember at the end of that last step, our answer was 2.4. So I just want to make sure that we get the same thing. So if you take 4 times 60, you get 240, which means that they are receiving, in an hour, they're going to receive 240 micrograms in a full hour. I know what it is per minute, but just by multiplying by 60, that told me what it is in an hour. So now what I'm going to have to do is figure out what is that in milliliters. So that's where this step comes in, where I have to incorporate the supply dosage in order to do this step, to get it from micrograms into milliliters. So we just have to take that 240, again, it's in micrograms. I'm incorporating the supply dose of 0.5 milligrams per 5 milliliters. Once again, just like in any dosage formula, I need my D and H, I need that to match. So I want to go ahead and make sure that D and H are the same unit. So I'm going to go ahead and convert my 240 micrograms into milligrams, as I'm just in that habit of getting everything into milligrams. So 240 micrograms would be 0.24 milligrams. So completing this, I'm going to take 0.24, divide that by 0.5, and then take that answer and multiply by 5, and I still get an answer of 2.4 milliliters per hour. So you still get the same answer. So just showing you guys that it didn't matter which one you do first, as long as you convert one to the other. Alright, and the last thing I want to show you guys along the same lines, and this was in some of those videos that I sent you guys last week too, that now I'm going to add one more thing. Now let's say we have an order dose of not just, say, 4 micrograms per minute, but now let's say it says 4 micrograms per kilogram per minute. Whoa. Now 3 things have to be changed. If we're trying to get it to milliliters per hour, then now we not only have to change our micrograms to milliliters and our minutes into hours, but now where does this kilogram come in? We have to incorporate now a weight. Don't let that throw you off. All it means is that we've got to do 3 things here. We've got to do 3 things to this particular problem. So let me get all those crazy lines out of the way. The order dose was 4 micrograms per kilogram per minute. But it says that we also have a medication that comes as, let's say, let's say 25 milligrams per 10 milliliters. And we have a patient that weighs, so their weight is, let's say, 45 kilograms. Okay, so 3 things need to be done here. And just like in the last couple examples, it does not matter what you do first. We just need to get it to here. We need to get it to milliliters per hour. So with those 3 things, it doesn't matter, but I'm looking at this 4 micrograms per kilogram every minute. Since I have a patient that weighs 45 kilograms, that means they're going to take 45 times this dosage. So you may want to go ahead and get that out of the way first. That let's think, okay, if they're taking 4 micrograms per kilogram of weight, that's 45 times that amount. So if you look at that way, 45 times 4 is 180. So what we've done there by multiplying it by 45, that's how you get rid of this per kilogram. I've got it down now to 180 micrograms per minute. And now it just goes back to what we saw just recently on the previous example. That now I just have 2 things to be done to this. My ordered dose for this particular person, we've already gotten that out of the way, is just 180 micrograms per minute. So let me get this out of the way to show you guys what we have. We have 180 micrograms that need to be given over a minute, but I need to get it to milliliters per hour. I want to know what that is in a flow rate. So 2 things again. We need to do this, and we need to do this. Based on the medication, which was, again, it was 25 milligrams per 10 milliliters. So you could either do this first and put it into the dosage calculation, or you can either convert your minutes to hours first and multiply by 60. I'm going to go ahead and do that first just because I'm thinking about it. If 180 micrograms are being given per minute, that's 60 times that amount in an hour. So 180 times 60 is 10,800. That's 10,800 micrograms every hour. So now I've got it down to hours, and I've already done this step then. All I need to do is put that into a dosage calculation. So I'm going to take that and incorporate the dosage, which is 25 milligrams per 10 milliliters. I want to make sure my D and H are the same unit, so I'm going to go ahead and do as I always do. I'm going to convert my micrograms up there to milligrams, and that will give me 10.8, because micro to milli, remember, is 3 places to the left. So now I can go ahead and finish this problem. 10.8 divided by 25. Taking that and multiplying it by 10, looks like this person needs 4.3 milliliters per hour. So don't let that throw you off when you see that per kilogram. And so you've got those review videos to help you with that. But that per kilogram, you can go ahead and just get that out of the way by just incorporating that patient's kilogram weight. You just take that and multiply it by whatever the kilogram weight is. Okay, guys, I hope that helps. There are more questions on that. If you, there are more examples with that with those review videos that I sent to you guys. If you guys do have questions on that, please, please, please let me know. I know these can be kind of tricky, and I'd be glad to answer that. I'll be here the rest of the week. I'm just not here today. I apologize for that. But I'll be here all week, and I'd be glad to go over some more with you guys. I apologize. I do not have a final practice review for you guys just yet. I'm actually going to work on that and get that sent to your email, hopefully by, I'm going to say, Wednesday, because I know you guys want some time to practice that. So definitely by Thursday morning, if you don't see it Wednesday afternoon, I'm going to get that sent to you guys. But just be looking over the things that we've done since the midterm. This is only going to cover the last 2 days of class that we've had. So not too extensive, but just to go over what you guys had on today's quiz, so the dosage calculations and everything we did with that, and then today the IV formulas and those calculations. So I'll send you guys over here pretty shortly some practice problems with that to prepare you guys for next week's final. All right, guys, if you have any questions, let me know. All right, have a great day.